In the previous video, we were introduced to the primitive types Java uses to store real numbers, the float and the double. In this video, we'll take a look at the differences in precision when using arithmetic. Alright, so let's continue on with our floating point discussion and using the float and double primitive types. We're going to declare my int value, my float value and my double value from the previous video because we'll be using it again in this video. Int my int value equals 5 semicolon float my float value equals 5f semicolon double my double value equals 5d semicolon. Alright, we can see there that my int value is showing the value of 5. No surprises there. But the float and the double are showing the decimal points, so 5.0 and 5.0 both for the float and for the double value. Let's pause for just a minute and talk about the default output for numeric data types. In this slide, we show default output as it would be in JShell or by using system.out.print for both whole and real numbers. You can see from this table that there are more ways to express a decimal real number literal than a whole number with the use of the nef or d suffix, as well as using Java's scientific notation in the literal value. Another interesting difference is that, for whole numbers, the output is never in scientific notation. But for real numbers, it could be, as you can see. Later in the course, we'll learn how to make these numbers print with the exact format we want and specify the exact number of decimal places to be printed. Alright, so let's now try doing some division to see what happens. We are going to assign the output of a simple division equation to each of the variables we created, starting with simple integer division. So let's type my int value equals 5 divided by 2 semicolon. Okay, maybe for developers from other languages, this isn't such a simple thing. The result is a whole number of 2. Did you expect it to be 2.5? Java uses a rather complex process when determining what type of data to output from calculations based on the types of the numbers used in the equation. We're not going to get into that right now, except to say that because both 5 and 2 are integers, the result is an integer value, and that value is 2. The decimal part is not included. Let's try something similar with the float variable. My float value equals 5f divided by 2f semicolon. So here, we did get 2.5, as we expected, because we used the division operator on 2 floats. The suffix made these numeric literals floats here. In this case, Java returns a float, so we do not need to cast the result. And let's use a similar equation with double literals and assigning it to our double variable. My double value equals 5d divided by 2d semicolon. We also get 2.5 as the output. So you can see what's happened there. The int type has got a value of 2, but both float and the double have got the value of 2.5. In the case of the float and the double, we've got a much more precise answer because it can handle the fractional part of a number. And obviously, that's the reason why you'd want to use a floating point number to be more precise with things like division. Alright, so moving on, let's explore this a little more. We'll change the divisor, which is the number we are dividing by, from 2 to 3. First, we'll do it for the integers, so 5 divided by 3 is assigned to an int variable. Can you guess the result? My int value equals 5 divided by 3 semicolon. Again, the result truncates any fractional part and returns a whole number, a value of 1. Next, let's do the same thing for the float. My float value equals 5f divided by 3f semicolon. You might remember that the real result of dividing 5 by 3 is 1.666666 with the 6's going on indefinitely. This is called a repeating decimal. In computer language, you can never represent this kind of number exactly, but you can represent it more or less precisely depending on the data type used. In this instance, the number is printed with 7 decimal places in the output. And now, let's see what the double division looks like. My double value equals 5d divided by 3d semicolon. For a double, the number is printed with 16 decimal places in the output. Actually, this output is a little misleading. For the float, the number stored in memory is actually more precise than that shown, but the output stops at 7 decimals. The same is true for a double. The number in memory is more precise than that represented by the number shown here in the output. but this example should make it clear that a double will more accurately represent numbers like these. Alright, and just a reminder again that in terms of the number that we're typing in here, if we're typing in a decimal number, we can do something like this. My double value equals 5.00 divided by 3.00 semicolon. We don't need the D suffix, remembering that Java will automatically look at a decimal number and assume it's a double. And we get exactly the same output as before. Let's take a moment here to change one of the operands to a literal int, leaving the other operand as a double or decimal number. So we'll again edit our previous statement and change 3.00 to just 3, a literal integer. So, as long as one of the operands is a double, your result will be a double. And another reminder that this won't work for your float variable. Let's try. My float value equals 5.00 divided by 3f semicolon. So here, even though one of our literals is a float, 3 with the f suffix in this case, the other is a double 5.0, and the result is a double, and you cannot assign a double to a float variable. So you might be thinking that given the fact that double takes up double the amount of space compared to the float, which is a single precision number, that perhaps you should be using the float data type. However, the double primitive type in this case is recommended, and there's a number of reasons for it. Why should we choose double? First, it's actually faster to process on many modern computers. That's because computers have, at the chip level, the functionality to actually deal with these double numbers faster than the equivalent float. Second, the Java libraries that we'll get into later in the course, particularly math functions, are often written to process doubles and not floats, and to return the result as a double. Java selected the double because it's more precise and it can handle a larger range of numbers. So consequently, you'll find that double was used a lot in the code that's out there in the various libraries. So for all those reasons, it's highly recommended that you use the double. For that reason, I'm not going to be using the float anymore in this course. Any floating point number code that we use moving forward will be a double. Alright, so to end this video, it's time for a quick little challenge. The objective of this challenge is to convert a given number of pounds to kilograms. Steps. 1. Create a variable with the appropriate type to store the number of pounds that we want to convert into kilograms. 2. Calculate kilograms using the variable above and store the result in a second appropriately typed variable. 3. Print the result. Don't forget to use the conversion formula shown here. So pause the video now, type your code in and give it a test run and see if you can get the result. Alright, so welcome back. Hopefully you managed to solve that challenge successfully on your own, but let's go through it and come up with a solution. We're going to be using a double here for floating point numbers, and hopefully you've taken in my reasoning for using the double. So we're going to start by typing double number of pounds equals 200D semicolon. Now 200 is just an arbitrary number. You could have used any number for the calculation. And next, we're going to create another variable called converted kilograms. The formula we'll use will be the number of pounds we want converted times the number I gave you. Double converted kilograms equals number of pounds times 0.45359237D semicolon. We don't have to put the letter D there as a suffix because we're dealing with a double data type anyway and it would be assumed. But we'll do that for consistency. And we'll print out the results with a label again. System.out.print, opening parentheses, double quotes, converted kilograms equals plus converted kilograms, closing parentheses, semicolon. And you can see we've got a result there, 90.718474. Now, just to be sure that this result is actually correct, we'll open a browser. We're going to Google and we'll say 200 pounds to kilograms. We've got the result there, 90.7185. Looking at our code, our result is 90.71847, so obviously that would be 7,185. Google has just rounded up. So clearly our calculation has worked well. Okay, so that's good. We successfully converted pounds to kilograms, and hopefully you managed to solve that challenge. Another quick thing I wanted to show you is you're already aware now that we can type double pi equals 3.1415927D semicolon. But remember, we can also express a number using underscores. Here, we'll be including underscores both before and after the decimal point. Double another number equals 3_000.4_567_890D semicolon. So you can format it in that way if you want. I'm just showing you that because you may see that out in the wild when you're coding and wonder what it is. If we take a look at another number, we can see that it's stored exactly the same way we typed it in, minus the underscores. The 0 at the end of another number was ignored because it's not needed. Alright, so I just want to finish off by talking about another important point about floating point numbers. In general, float and double are great for general floating point operations. But neither should be used when precise calculations are required. This is due to a limitation with how floating point numbers are stored and not a Java problem as such. Java has a class called Big Decimal that overcomes this. You remember that we've said previously that a class is a kind of a custom data type, and Java comes with a whole library of helpful classes. For now, just keep in the back of your mind that when precise calculations are necessary, you'll probably need to use the Big Decimal class and not a float or double. For general calculations, the float and double types are fine. Again, we'll discuss this later in the course. Alright, so that's it now for the floating point data types. In the next video, we'll look at two more primitive types in Java, namely the char and the boolean. So I'll see you in the next video.